I am in Eagle River, Wisconsin, checking out Epitome Quality Foundation Homes, where this house behind me has a foundation entirely made of not concrete. Let's check it out. How you doing, Ian?
Morning, David.
Here to see some concrete-less walls.
All right,
Care
cool.
to take a look?
Yeah, we'd love to show them to you.
All right, so we got this all opened up so everybody can see the bare wall. All right, Ian.
Thanks for being here today, David.
Yeah, what do we got here? We don't have any concrete here, do we?
Correct. This is a new high-performance alternative to concrete walls. It combines your insulation, top plate, stud cavity for mechanicals, and insulation all in one easy-to-install step. These foundations are installed in as little as 4 hours for a full foundation, and we install them in one trip to the job site. You can set the panels of the floor system on top of it that day. No cure time, saving you 2 to 3 weeks in construction time sometimes.
That's awesome. All right, so let's dive a little deeper into the components of this. So this is composed of a sandwiched insulation panel with studs. Is it 16 on center then?
16 on center, yep.
Okay, and then how are these attached to the panel itself?
They're screwed and glued with a plyo grip, construction grade adhesive, or boat grade adhesive actually, so it won't tear off of there. You're going to tear the panel off of the fibers out of the panel before you tear the stud off.
Okay. And before we look deeper, I know you got a cross section that we can look at too, that we can show you guys. But now we're looking at this. How do you attach this wall to the footings and the top plate?
We use the L70 brackets at the top and the bottom. In the top, we go every stud cavity, and then every other stud cavity, we are using a H25 hurricane clip. And then we also screw in with a long screw into every floor joist above. At the bottom, we use the same L70 bracket every other stud cavity, and we just put that right to the footing. If you're using our composite footing, we just screw it down to the footing. If you're using a concrete footing, we ram set it. We use a Hilti gun.
Okay. And then, so let's talk a little bit about the footing. So you guys have a composite footing that you can use for this as well. Tell me a little bit about the dimensions and the strength of those.
So the strength of that is probably 3 times the strength of concrete.
Okay.
It's 2 inches thick. It's a honeycomb foam with fiberglass sheeting on both sides of it. So the crush strength is unbelievable on it. We drive skid steers right on top of them and right over the top of them. We don't get any crush or any crush there. So they're 18 inches wide by 2 inches thick.
Okay. And then they attach with the same fasteners as you do with these. Now, what type of fasteners are those? Do they have to be stainless steel?
We use the Simpson L70. There's a couple other companies, but we spec a couple of different ones. But typically, it's the Simpson Strong Tie L70 bracket.
Okay, just to keep everything within the warranty of their brackets.
Yep.
Okay, that's good.
So, and that does come fabricated that way. If you're purchasing them from us, we fabricate them in Eagle River, Wisconsin. And so they will come out with the top plate, all of your plating, all of your brackets, all of that on there. The only thing you're adding in addition is the lag screws to go into the joists.
Okay, so tell us a little bit too, because not everybody builds or needs a 9-foot wall?
Correct.
So what lengths do you guys have to offer
typically
people?
We can cut them at any length, any height you need. We offer a 9-foot, a 4'6" for a crawl space, and in northern Wisconsin we have approval to do a 3-foot frost wall for if you're doing a slab on grade or a similar floor system to what you use.
Okay. Now, talk to us a little bit about, because I know some people are questioning, okay, what is the strength of this compared to concrete? Because everybody's used to concrete, right? Mm-hmm. So what are the different factors of measuring the strength of this compared to concrete?
Well, once you get the load on top, we have a 5 times stronger axial load than concrete. Okay. So we've had them tested in Indiana at NTA. That gave us all of our ESR reports that give us national building accreditation, and they use pressure, right? They simulate up to 3 times a clay load, and they can't break the panel. Typically a concrete wall I think breaks at about 10,000 pounds, and
Mm-hmm.
they put about 45,000 pounds to the side, the axial side of ours.
So that's essentially standing a wall up, holding it there, and pushing against it.
Correct.
That's the
yep.
load
Once
that
you get
you're
your
talking about.
downforce too. Yep.
Yeah.
With the downforce, once the downforce is on it, that side pressure, just like your backfill, simulating that backfill pressure.
Okay. And that's assuming that you're correctly attached to your footing, and that footing's it's not going to push off the footing.
Correct. We do
like
have
that.
we do have a backfill schedule. You need to have your floor system on and tied in,
Okay.
and you need to have your concrete floor. We do still use a concrete floor in a lot of them. I know you're looking at a couple of different ways to do it, but you do need to have both the top and the bottom secured so that it can't push in. Because
Okay.
they will slide around. That's one of the benefits of the panel, actually, in setting them on. Once you get them on there, you straighten them up and keep working your way around, just like a component style set.
Okay. Because I can assume probably these are very straight as a unit themselves, so you're not going to have any variation as you would
Correct.
with a poured wall where you're having to brace everything and get everything
Correct.
straight while it's
We
curing.
snap the lines on. We snap the lines on the footing, and when this one sets down there, if the crane operator's good, you don't move it at all. Right.
Great,
You
great.
might need to bump it to the line a little bit, but once it's on the line in one spot, it's on the line the rest of the way.
Okay. Well, show us a little bit about, you got some electrical outlets in
Yep.
here and some HVAC ducts.
Yeah, the stud cavities are a standard. Again, we're 16 on center, so your stud cavities are there for running any mechanicals. Right now, we do run them vertically with the stud up through the top plate, but you can also put your HVAC in, and so you can run it down the way you want to. Get it down to the floor there, and fill that cam, and then you're ready to put drywall right over the top of it.
Okay.
No more framing. Drywall screws right to this product.
Okay, so drywall screws can run right into this composite
Yep.
stud.
Yep, they use the same screws as they use for a metal stud. So it's self-tapping screw, goes right into that one. Drywall goes right to it.
Okay.
No need for another vapor barrier. You can add some insulation here if you want to. I don't know if we mentioned it, but we're an R22.7 when it goes in the ground.
Okay.
A simple bat installation increases you to an R30.
Okay. And you have this painted right now, so this can accept most, if not all.
Yeah, we
paints.
didn't paint this. This is the product the way it comes. So
Okay.
this is the finish of the product. But yes, it'll accept paint. It'll accept a fire retardant paint. It'll accept any paint you want to put on it, on the interior and the exterior.
Okay. Now, you talked about the insulation. Now, how thick of an insulation is in this panel?
So this is 3.5 inches of closed cell foam, polystyrene
Okay.
foam on in the panel. So that's how much. That's the thickness of the.
Okay. So when this comes, it can come with the top plates, and you can also have the footing affixed to it, or does the footing
No,
come in a
we
separate
we
unit?
lay the footing in and then set the wall on top of that. So
Okay.
once you're got it graded and you got your hole dug, once it's all graded, we just lay the footing in. We actually use a rebar to pin it in place for a little while.
Okay.
And then we set the wall on top of it, and then that's not going anywhere.
Okay. So with your top plates, some people might be saying too, or we'd like to tie the top plates in after the wall's up. So do you leave edges open so that we can counter over with top plates, so that one panel has a little bit of a space to connect to?
Yeah, that's
perpendicular?
exactly how they're installed.
Okay.
You know, so we call it button pass, and so we'll leave a temp piece. Like you can't see one here, but when we have a wall, let's say it's a 48-foot wall, you know, we'll have 6 feet of a plate that can just screw right off.
Okay.
One comes in like this, the other one lays on top. You screw it down. Same thing at the corners.
Okay. Is 6 feet kind of your standard? You'd
6
like to have
feet is,
overlap?
yep, yes,
Okay.
4 to 6 feet even. 4 feet. He usually does 4 feet even. You know,
Okay.
because the panel is there, and the bottom, the bottom top plate,
Right.
is solid. You know, so
Okay.
we don't overlap those. You know, we overlap those in different spots.
Right.
So that 4 feet to 6 feet is plenty for the button pass.
Okay, so let's talk about the wall above. Point load, do you need to adjust your layout of the foundation to the layout
No,
of the roof trusses, so everything's a point load?
Nope, strong enough in all spots, so you don't need to get the point load over a stud or anything like that.
Okay.
The studs are really not giving your down strength. The studs are giving you your axial strength to keep the wall from bowing is what the stud is doing.
Okay, so we don't have to line any of the studs to the joists to the...
No, we put them in. When we're building them in the fabrication facility, it's one continuous process. If we got a 26-foot wall, so we take our 24-foot, cut 2 foot off of another one, that leftover piece is the one we start with the next, so you just continue on. So you get your studs in the corner, you do a little bit of framing in the corner. Sometimes you end up having to throw another board in there to accept drywall, but not many times.
Okay. So how long of lengths do these come in?
So they're manufactured in 24-foot long lengths.
Okay.
But obviously we can combine them with an H connector and go as long as you want to go.
Okay, so to combine those, an H connectors, is that made of the same composite material?
Yes, it's similar. Yep.
Okay.
It's also made through pultrusion. Those are made in La Crosse, Wisconsin, actually. But yeah, they're the same composite material. So
talk to us a little bit about how you connect those together. Is it just a dry fit, or do you caulk those?
We silicone the outside edge.
Okay.
And we put a bead of silicone in the H connector in both H sides. One side would be installed in the factory.
Okay.
And so when it comes out to you in the field, we put a bead of silicone in there, and then we just pull them together, and then we hit them with screws in 6 spots.
Okay, so you guys will take our plans and pre-cut all of the panels to size and then affix them with the junctions that you need. And then all it is when we get to the site is a couple hours of
putting together a puzzle.
Okay. Let's see. Well, do you want to take a look at a cross section?
Sure. Okay. So this is a good example cross section here. So you got your polystyrene foam. It's circled in fiberglass all the way around, right? Then you have what's called the veil on the outside. You have your skins on the outside here. And then everything is injected with, or they put some resins in there. And then it's put in a pultrusion machine, which gives it pressure and heat. And it literally pulls it through that pressure and the heat. And it comes out just like that. It's dry and ready to go. You could stand it up right there in the factory and build on the top of it right when it comes off the line. And then they actually take and adhere the stud once the thick panel is made.
Okay. And so then your H-click, when you do combine them, it would be set in here.
Yep.
And then the other face would be facing this way, and then you'd accept the new panel.
Correct.
Is that right?
Yep.
Okay.
Same with the corners, coming 90 degrees.
Okay. Now, one question that I did ask you guys earlier too is, how do I break this? What happens when it breaks? How, like with every other material in construction, everybody wants to know what happens when or if it fails. So what would you
we haven't been able to break one, you know? So like I said, you may be able to pull some of this stud off of here, but it's gonna pull the fibers that are in this, the fiberglass, the threads, it's gonna pull all of those off of here before it pulls the rest of it. You know, the pull-out strength is great on it. As far as crush strength, again, we haven't broke them. You know,
yeah.
I work with the guy that comes to test our facility once a year just to make sure we're in compliance. Before he was doing that job, he was the testing guy that did our product, and every time he's here, he's like, "I couldn't break your product." He's like, "I tried and I tried and I tried, but I couldn't break your product." So we have a 30-year warranty on it. We with the waterproofing and that, we haven't had any leak yet. And so we just haven't run into breaking them. So it wouldn't shatter. It would maybe, I mean, it might crack a little bit, but we just never seen it do it. So I don't know how it would act.
Now, you talk about waterproofing. Do we have to waterproof the outside of this, or is it waterproof itself?
Just at the connection to the footer.
Okay.
So we use a emulsion tar where it connects to the footer, and then we actually use a Henry's blueskin adhesive at the joints, those H connectors that we were talking about.
Okay. Okay, so we talked about a little bit about water. Obviously, this is going to be airtight. So in a basement, you're not going to have any condensation coming through here because there's not going to be air bringing any of that in. What about fire?
They do need to be covered in drywall to give you that I think it's a 3-hour fire rating.
Okay.
So they do need to be covered in drywall.
Okay. which if anybody's going to be finishing their basement,
it is where this product comes in, right? If you're finishing the basement, you really are then we're competitive with concrete.
Now you probably could have some type of spray on
Absolutely,
flame retardant as well.
Absolutely. There's a fire paint made by DuPont that would act that same way.
Okay, so this is the inside. Now this is the outside. If this is sticking up 8 inches like it should, like any foundation before it comes to siding, what if this sticks up, a couple feet, and I want to cover this with something? Is there something I can attach this to?
You can put any standard exterior building product over the top of it, LP siding. You can put your mesh for a cultured stone on it, and you can also just paint it too. Okay. So we in our installation guide, we say within 3 years to get some covering on it. We haven't had any start to deteriorate or get any fiber bloom out of them yet, but I have it in my house. I haven't got it painted yet on the one sunny side. I got about 2 feet sticking out of the ground, and I don't have any fiber bloom or anything like that. I've been just kind of experimenting with it because it wouldn't give you any structural problems. It would just be strictly cosmetic.
Now, is there any certain type of fasteners that you will need to use on the outside then?
Just a self-tapping screw.
Okay.
That's what goes into that.
Does this have any properties, or is there any cause of concern with water getting through the fasteners, or does this?
No, with the closed cell foam on the inside of that one, it doesn't have anywhere to go. So once you seal that one, we don't put a silicone or anything like that when we screw to it.
All right. Any other questions that you feel like most people ask about this?
I think you kind of covered it there.
Okay.
We talked about it a little bit, and I think that it really does sum up the product.
Okay, so cost-wise, what are people looking at for cost with this?
Right now we're at $200 a linear foot for a 9-foot basement.
Okay.
That's fabricated with your double top plate, insulation, all of the qualities that are inherent to the product. So a $200 on a 9-foot basement, like you see here. Frost walls at 4'6" or crawl space wall, whatever you're using it for, is $99 a linear foot, and the 3-foot foundation that we're using is $79 a linear foot.
Okay. Now with that, you got to remember that you don't have all the labor. You don't have all the timing of the labor, meaning you don't have to get the footings in, let them dry, and get them staked out with the rebar and have the the groove cut in them, or waiting to put the forms on, getting the forms on, finding someone with the forms to be able to do that in some cases.
Your carpentry crew can put them in the ground. We usually send a guy for the first install, but if they can build a house, they can put these in the ground.
Yeah.
So you gain back that time too. And again, when you're talking about that $200 a linear foot, there's no other additional vapor barrier required. There's no framing out the inside of the basement. No more insulation needed. So all of those are inherent to the product.
Yeah, so when I'm comparing the other systems with my build that I'm modeling, when I take this, I don't have to do my exterior insulation. I don't have to do a rain screen or waterproofing. I don't have to put a concrete footing in, which in my case, I don't even need the drain. So mine's a little different. I don't need to do a form a drain for my footings. And I don't have to excavate as much either, because I don't have to have room on each side of my footings for guys to run around with forms and bracing and all that as well. So that not only eliminates a lot of the excavation, but also backfill. So there's a lot of steps that this takes place, so you can't just do linear foot to linear foot of a foundation system or a foundation wall. You have to do the whole system together. And so in my case, I'm actually maybe a few $100 difference.
Yeah, that's what it seemed like.
But I can do this in a couple hours.
Yeah.
And so when you bring the time aspect into the whole comparison, this is a big time savings. So I'm really excited to see how this lays out.
You know, I mean, we'll get them where we may have an excavator there itching to get rolling. Once we get down one wall and going down the other way, and this one's all braced, sometimes he's filling those, especially with a frost wall situation, he's filling those as we're still installing, going around around the house. So
there's one less trip for the excavator to come in and
absolutely.
That's a good point. Now, all right, so a lot of my audience is very health conscious, and I know that we talked a little bit too about some people having concerns with all the ways that concrete is made and things like that, which is a little touchy subject with a lot of concrete guys.
Yep.
But in the health world, what is this going to do for some people that may be sensitive to any glues or anything?
So
this is already dry, I assume.
When we talk about VOCs and things like that, when they're manufacturing this product in Elkhart, Indiana, they don't have to wear a mask. When our guys are, there's no need to wear any of that. So the polystyrene foam, cutting those, it can give you some irritation when you're cutting it. But once it's solid and done, you're done, right? You're not getting that dust and mildew and things like that that can happen with a concrete wall. It's easily sanitizable. You can wipe it with anything you need to do, and mold and mildew resistant.
Great. So when we're talking about concrete, there's also, everybody is like, this is kind of plasticky, right? So some people are like, well, is this a forever plastic? Is it going to last forever? Well, as a foundation, I would hope so.
That's our goal.
Because this needs to be something that needs to last forever. And obviously, if it's something that you're not going to be eating your supper off this, right? So you have to get a little bit of a balance of, okay, we're talking about a foundation that's literally going to be buried underground, and you're hopefully not going to have to do anything to it forever, just like you would concrete. But this also has a lot less of an environmental impact, as in concrete weighs what, like 15 times more than this?
Yeah, I think it's 10 times more, or somewhere in that ballpark. So
this itself, when we're talking about just laying it as a foundation, this is not going to take up a lot of the weight that you're having to worry about with your whole house. You have to take into consideration also the load and weight of your foundation wall itself.
Yeah,
on the soil types.
Correct.
Right? Now, if you can lessen the load on the soil, then you have more options, where you said I could do the 3 foot.
So like a 24-foot, 9-foot wall of this is about 926 pounds. Okay. So yeah, you're close to 10 times lighter than concrete in that. So with a concrete wall, you're using up the first 15% of your soil bearing capacity with the concrete wall, whereas this isn't doing that. Okay. So that's an advantage there too.
Awesome. All right. Well, I appreciate you taking time to meet with me again and going over this a little bit more for everybody that can see that this is a option for your foundations, not only to save time, but to save a lot of complexity. And many people could just probably install this themselves without even a full foundation.
Like I said, if they can build a house, they can definitely install these ones. It's a pretty simple system.
All right, so now that we've been looking at the inside here of this, right? That's what this is. But I think some people are probably curious of, what does the outside look like? So do you want to take me outside and show me what the exterior of the foundation?
And siding, but we can find a spot we can see it.
All right, great. Let's go check it outside. All right, so we are outside. And is this the wall that we were looking at then?
Yep, this is the exterior of the wall that we were looking at. You'll see that we have smart siding on the side of it, going right down to the trim board. You can just barely see the little top of the blue skin here. So that's the blue skin adhesive that we use in the at the joints. And other than that, it's just a flat exterior finish.
All right, and you got just stone right up against it there.
Yep.
Yeah, so I don't even see really much of a transition between the wall for the foundation and the wall, the upper framing.
Yeah, so you can see here then too that our window festration is cut right in the foundation system.
Okay. And is there a lintel on top of that window, or does there need to be anything?
We're strong enough there with our panel that we can manage it. Some building inspectors do want to see you put a little bit of a header above it too, but we can cross that bridge. All we do is cut the stud down, peel that one out of there, and we can put a header above it too if we need to.
Because you can just reinforce through using jack studs, or those as jack studs on the inside. Okay. Yep. So how tall is this somewhat header of the panel above this window then?
I think they do about a 12-inch header.
Okay. And you don't need anything in there other than
Correct.
the foam and the studs there.
Yep.
Okay, great. Well, that's the outside. Really no different. I mean, you got stone over here as well,
Yep.
so you can see that the stone goes up just as nice as any other siding. So really, is there any other siding that you got to worry about putting up on this product?
No, we put vinyl on it. We put like a half log scan log on there too, and
Okay.
yep.
So it'll hold the half logs.
Yep.
Okay. All right, looks good. Appreciate you showing me the outside.
Yeah, you bet.